You're welcome again one more time. In our last video spoke on the specific heat capacity and heat capacity. Uh, Specific heat capacity and heat capacity. We looked at the formulas and I mentioned some key things. Please, if you have not watched the video, you can go back and watch it. And if you have not subscribed, please endeavor to also subscribe and also like the video. Yes, we talked about this formula, a capacity, specific energy, heat energy given us what mass multiplied by what specific capacity multiplied by what change in what temperature. And I told that heat capacity is what mass times specific heat capacity. We also went to what is called the electrical method. IBT giving what M giving this. This is same as what b square over what v square v square t over r, giving us same thing. Change in temperature is I square RT MC change in what temperature. Please, I'll define specific capacity as what the quantity of heat required to change what a unit mass by what 1 watt Kelvin or what 1 degree what Celsius. And heat capacity is a product of what mass and what specific heat capacity. This is the quantity of heat needed to change what the whole body, the whole mass of the body by what 1 watt Kelvin. So today I want us to what move again and discuss what something very what that most time they do come out, which is what temperature difference in a waterfall. Temperature difference in a what waterfall. So sometimes questions under this do confuse students and students like how should I solve this? You know your energy, mechanical energy could be potential and could be also be what? Kinetic. 1/2 what? mv squared. This potential energy, mass times associated to gravity multiplied by height. And this is what kinetic energy. And now, well, we've also discussed that energy, which is in form of heat, is also what mass times specific heat capacity times what change in temperature. That means if energy equals this and energy equals this, I can just say that what my mgh equals what mc change in temperature. Where m cancel m, and I have what gh equals what c times what change in temperature, and you can make any of them subject to the formula. You can calculate the height, you can calculate the temperature after the water falling covering a particular height. You can also calculate for what specific capacity if you are giving your access to gravity, your height, and what change in what temperature. We are going to look at questions why Neko jam under this. Then from this point, I will move towards another point, which is what latent heat. Under latent heat, I don't want to waste your time. Latent heat are you've boiled your water, you've seen water boiled, and We have aware that water, normal water boils at 100 degrees Celsius. You put your water on fire, it gets to 100, start boiling, and it's still on fire. Does it mean that at that 100 it will move to stay as it is still on fire? We move to 100 and 102, 103, 110, 120? No. At that 100 degrees Celsius, those extra heat being applied, the water will store the energy and use the energy to now change in state. We are talking about latent. We are talking about what? The quantity of heat that what? Which that changes the state of what? The material. Changing liquid to gas. Changing solid to liquid. Changing liquid to solid. Changing gas to what? Liquid. So when I talk about change in state at a constant temperature, we are not talking about what? The latent heat. It could be latent heat of fusion, which is between what? Solid and liquid. The liquid what? Fusing together. Or it could be latent heat of vaporization, liquid vaporizing, or gas to liquid. So those are the two types of latent heat you have: latent heat of fusion and latent heat of vaporization. Both of them, the solid move changing state to liquid at a constant temperature, or latent heat of vaporization, the liquid changing to gas at a constant what? Temperature. So that is what you that's what you have under latent heat. So please, in our next video, we'll look at what? Examples of latent heat of fusion, latent heat of vaporization, specific capacity and heat capacity. And the next part we move into is what? Relative what? Humidity. So under relative humidity, is as simple as ABC. So all we have there is what? We have what up to what? Three formulas here. Mass of water vapor in a given volume of air over mass of water vapor required to saturate. Saturated vapor pressure of water over saturation vapor pressure. Vapor pressure of the air over saturated vapor pressure at the what? Temperature of the what? Air. What? No matter what it is, keep your what? Self that you just keep calm. It's nothing to what? Worry about. Your vapor pressure over saturated vapor pressure is 100%. Now, when we look at this formula, sometimes students get confused, but keep calm. It's Mr. Jude. I will solve as much questions as possible, and I will expose some things you should watch out for when solving these questions, including the units. When are you going to convert your kilogram to gram? Because it's not all the time you convert a kilogram to gram when it comes to latent heat and specific heat capacity. There are some things you watch out for. You watch out for what? Your specific heat capacity. Your specific capacity, is it joule per kilogram per Kelvin or joule per gram per Kelvin? If the joule per gram per Kelvin, let your mass be in gram. Don't convert it. So it should be easier for you to work on. If your specific heat capacity is joule per kilogram per Kelvin, then we leave our mass what? By what? Our mass should be what? Kilogram. Recall energy, our heat energy is MC change in temperature. If you make specific capacity is subject to the formula, you are going to have heat over what? M times change in what? Temperature. Are you with me? So now, Our heat is what in joule, mass is in kilogram, and this is what per Kelvin or per what Celsius. I told you change in Kelvin is same as what change in Celsius scale. In Kelvin scale, so that's change in Celsius scale. Reason being that what both Kelvin and Celsius scale have the same what fundamental what interval. Sorry, please. So this is what joule per kilogram per Kelvin per Kelvin. Take note of that. Take note of that. Take note of that. So I'll be going into what surveys now, and I'll be taking 2-3 questions at a time, except some special questions that will demand me solving them what on their own without what mixing what them up. Take your time. And one thing you should take note in heat capacity and heat capacity is that heat loss heat loss equals what heat gain. You have to know the body that is gaining heat and the body that is losing heat. You must understand the question. Just for an example, you want to bathe and you get your water at normal temperature, which will be cold to you, and you want something warmer. You can decide to boil some quantity of water which bone won't be same as the cold one, like the one at the normal temperature you want to use to bathe. Now, pouring the hot water into the cold water, both of them now will mix up, now having a what? A particular what? Temperature, which is lesser than the hot water, but hotter, warmer than the what? Cold water. Take note, heat loss equals to heat gain, and go through this video and the one before this on specific heat capacity. I'll be moving now into what? Solvents. Thank you.